Magnetostriction method by using circuit diagram. Magnetostriction method. Magnetostriction method is used to produce ultrasonic waves in the frequency range 20 kHz to 100 kHz. In this method, we have to produce ultrasonic sound waves by using magnetostriction method principle. Magnetostriction is a property of ferromagnetic materials like iron, nickel, cobalt that causes these ferromagnetic materials to change their dimensions or shape during the process of magnetostriction. This effect was first identified by Joule in the year 1842. Magnetostriction methods can convert magnetic energy to kinetic energy by doing mechanical vibration. When a ferromagnetic material placed in a magnetic field parallel to its length, then a small expansion or contraction is occurred in its length. The change of length must be depends upon strength of the magnetic field and nature of the ferromagnetic materials. This is the principle involved in the magnetostriction method. Now we can explain the production of ultrasonic waves by using method from the following experiment. So let us see the circuit diagram of magnetostriction method. The experimental arrangement of magnetostriction method for the production of ultrasonic waves is as shown in the following circuit diagram. Here AB is the ferromagnetic material which is clamped at the center. This ferromagnetic material permanently magnetized by passing direct current DC through the coil which is around the material as shown in the diagram. Here V is equal to triode value, P is equal to plate, G is equal to grid, K is equal to cathode, HT is equal to high tension circuit. Now let us see the working of the experiment. When the battery is switched on, the resonant circuit L1C1 sets up an alternating circuit of frequency F is equal to 1 by 2 pi root over L1C1. This current flowing around the coil L1 produces an alternating magnetic pulse of frequency F along the length of the nickel rod. The rod starts vibrating due to magnetostrictive effect. The vibrations of the rod create ultrasonic waves. The longitudinal expansion and contraction of the rod produces an EM in the coil L2. This EMF is applied to the base of the transistor, hence the amplitude of high frequency of high oscillations in coil L1 is increased due to positive feedback. The developed alternating current frequency can be turned with the natural frequency of the rod by adjusting the capacitor. There are another two coil L1 and L2 which are wrapped around the magnetic materials. Here the coil L2 and variable capacitor C are connected in parallel, and this combination of LC circuit is again connected to a plate current at wall V. Through milliammeter also the coil L1 is connected in between grid G and a plate P cathode K. Now the oscillating frequency is determined by LC circuit which is F is equal to 1 by 2 pi root over LC. When the frequency of LC circuit is equals to natural frequency of the materials, then due to resonance, resonant vibrations are produced in the surrounding medium, that is the sound waves of maximum amplitude are generated. In general, the frequency of these sound waves must be in the range of greater than 20 kHz up to 100 kHz. So these waves are called ultrasonic waves.